Hi, everybody. Welcome to the Fringe. My name's Alyson, and I am one of the co founders and owners of Fringe. And I am with Genevieve, our scientific director at Fringe. And today we are going to talk to you about red and near infrared light and get into a little bit more detail about those two types of light. I think the thing that confuses some people is that when we generally talk about red light therapy, which we talk about a lot, we are talking about both red and near infrared spectrums of light. And there are differences in the two of them. And even, gosh, from when we started a few years ago learning about red light therapy, I feel like Genevieve and I have learned so much about what exactly is different about them and kind of where we're probably headed in the future of red light therapy and talking about how it works and why it works. And just like everything, we know a lot and we know nothing. So
Yeah.
that's that's where we're at. So let's begin by really having you, Jen, just explain to us the differences between those two lights and, just from the basics of what they are and that sort of thing.
Yeah, for sure. So, I think most people have heard about something called the electromagnetic spectrum. Um, but I suspect that if you were like me 5 years ago, 10 years ago, didn't really understand it very well. So, this is a spectrum in which we find sunlight falling, but we also find things like X rays and gamma rays and microwaves, which are, and like all of those radio waves. So it's this really massive spectrum of energy. And red light therapy can really only be understood by recognizing that light from the sun fits into this electromagnetic spectrum. So when we look at the light that comes from the sun, we see that it's actually not a massive range of wavelengths. It spans from, we measure these in nanometers, so that's 10 to the minus 9 meters. So it's 250 to 2,500 in total from the sun. Of that, though, really interestingly, there's only a small portion of that that's actually visible. So that spans from 380-ish to 700. So this little teeny tiny spectrum of this infinite spectrum is what our eyes perceive. So, when you wrap your head around that and you start to think like, what are we not seeing that's in our environment?
Right.
Right?
Energy is not visible.
Yeah, we're not seeing all the Wi-Fi signals and everything that comes in, and we actually don't see all of the wavelengths that come from the sun either. So we
Right.
see that visible spectrum that gives us our rainbow, the red, orange, green, yellow, blue, violet, all of those colors. But what we don't see are the invisible light that falls on either end of that spectrum. So if we come in on the short end, when I say short, that means the nanometers, the wavelengths are going to be shorter. They're going to be tighter. So if you were to draw a graph, you would see this like tight little wave going up and down. And when that wave is very tight, it carries a lot of energy. And this is going to become important. I'm going to circle back to that in a moment. But as we get into these first wavelengths of the sun, the really high energy ones, that's our ultraviolet light. So ultraviolet light is not visible to the naked eye. But then when we get into the visible light, we'll start at violet and we'll move all the way up to red. And those wavelengths will get longer and longer and longer and longer. So really the only thing that distinguishes one color of light from another is its wavelength. And of course, it's not a single wavelength. There'll be a range for each color. So for example, red is around 620 nanometers to 700. So that red's going to fall into that longer end of the visible spectrum. If we keep going out from there and we see the light that's still coming from the sun, so I said we're ending at about 700, but the sun keeps going to about 2,500. So we've got
Yep.
lots of these really, really, really long wavelengths, and they don't carry as much energy. They get longer and longer and longer, and we don't see them. But the
Right.
first the first ones that we get are near infrared light. We feel those a little bit of heat is generated from those. And then if we keep going from that, we've got far infrared and that will generate even more warmth. So we can essentially characterize this like beautiful spectrum of these different wavelengths of light based on one, whether they're visible or not visible, and two, the length of their wavelengths, and then three, the amount of energy that they carry. So if we go back to that UV light that has that tight, short wavelength, if we were to graph it, it's considered to be somewhat harmful because the energy that it carries is so great that when it gets in contact with our body, it has the ability to create these reactions called ionizing reactions. So it's considered ionizing radiation. And so when people think about light from the sun and why is it dangerous, well, that's the reaction that is causing that DNA damage. But of course, that's really only in excess. We're
Right.
understanding more and more every day that light, even the UV light, is actually really beneficial for us. You just don't want to overdo it. It's important to, not have excessive exposure to that ionizing radiation. But when we get to the red and the near infrared and we isolate those wavelengths, those are completely non-ionizing. They don't
Right.
have that effect. And this is why we can safely use them for their beneficial effects, which I know we're going to talk about in this podcast. And it's also one of the reasons why when we're doing light therapy on this kind of regular daily basis, we do want to choose these wavelengths that one, we know are effective, and two, we know are safe.
Yeah, absolutely. We truly get asked this every day, by people that are interested in using our products or just generally have questions for us and know we like to talk about this. We are very much so choosing a large range of wavelengths when we look at red and near infrared light, but we are choosing these wavelengths of light that our body responds incredibly well to from a healing standpoint. So it would be good for sure as we jump into talking about this to kind of just recap and remind everybody how our body does respond to light in general, but specifically red and near infrared ranges and sort of on a cellular level, what's happening. So, because then I think it helps us really unpack the differences between red and near infrared,
Mhm.
which, there's more similarities than differences, but there are some differences.
Yeah, what's fascinating is that there are many different types of what we call bioactive light. So,
Right.
bioactive light is just simply light that is biologically active. It creates a biological response. So, for example, that UV light, we know that when it interacts with our skin, we have the
Yeah.
synthesis of vitamin D. It's so fascinating that we make this hormone when it's made from the sun. It's not technically a vitamin coming in from the diet, but it's essentially the same. It's going to have the same biological effects. So that's what we see with our UV light. Our blue light has these really interesting antimicrobial effects. R- Light like yellow and green and orange, they haven't been nearly as well studied, but
Yeah.
they're starting to be investigated, and we're starting to realize that they're biologically active too.
Yeah.
But
I think the funny thing, how could they not be?
of
Right?
course, how could they
Right.
not be? Yeah.
Yeah, so we
Yeah.
we just have to learn more in order to say, "Oh, you should consider,
Yeah.
maybe utilizing a yellow." Because we have had people ask us, "How come you don't put green light therapy in your face mask?" And it's like, we might someday.
Absolutely.
When we could answer questions better, we absolutely might. Yeah.
Yeah, yeah, for sure. And so when we get into looking at that red and the near infrared, that falls into what's called this optical window where the light is able to come into the body and induce these biological responses by interacting with our cells literally on a molecular level. So we have molecules inside of our cells called chromophores, and chromophores interact with a specific wavelength of light. You'll have different chromophores that interact with different wavelengths. And so if you're figuring out what you want to do to treat a particular condition, for example, acne, we know that the acne producing parts of our skin will have a response specifically to the blue light because they have a chromophore in the microbes that cause acne. So you can essentially, it's just like a matching where you can match the chromophore to the light wavelength. But when we get into looking at the red and the near infrared, so there are many chromophores that interact with red and near infrared. But in terms of kind of taking this to the next level, some chromophores are what are called photoreceptors, meaning they react with light and they create this signal, like a cellular signal
Yep.
that's very measurable. And so both the red and the near infrared interact with something in our electron transport chain, which I'm going to explain to you in a moment, called cytochrome C oxidase. So that's our sciencey explanation. The kind of easier way to understand it is if you look at your cell, we've got this cellular machinery that makes energy. It's like probably if we had to figure, say what's the most important part of a cell, I think we have to say it's the mitochondria, which
Yep.
contains this machinery. Because
Yep.
if without the energy, we just can't do anything. We're dead. So our mitochondria contain this cellular machinery, and in that is this specific enzyme that's part of a big group of molecules. It's not the only thing that does this, but it's really important. And it interacts. It's a photoreceptor for both the red and the near infrared. Now, interestingly, there are some subtle differences in the specific way that those interact there, but that's kind of irrelevant to the big story. The big story is that through those interactions, we have this kind of increase, and it's not a dramatic increase. It's a nice, physiologically manageable increase in the production of cellular energy. So it allows that cell to do what it is programmed to do much more effectively. And if that cell is healthy, it will help it function more optimally. And if it's unhealthy, it can help to restore health, whether that be a muscle cell, a skin cell, a liver
Yeah.
cell, right? So
I
all of
think
our cells.
that is the part that it's like every day we are asked, could this help my hair growth, my eyesight, my skin, my, joint, tendon, ligament,
Yeah,
muscle, kidneys, lungs. I mean, the
yeah,
list literally goes head to toe, inside and out. And then you realize that this signaling system is us.
yeah,
Is how we are, and so we respond to light, in a variety of different ways, and this one we're talking about energizes all these different types of cells so they can go do their job like they were designed, to do.
yeah. We don't
Um
have we don't have a distinction between the
Right.
mitochondria in a skin cell versus a muscle cell that says, no, this one doesn't react to the light and this one does.
Yeah,
It's consistent across all of the mitochondria that this particular enzyme, this cytochrome C oxidase, is a photoreceptor for both the red and the near infrared light. It's just a matter of getting the light into that location.
that's correct. So let's talk because, occasionally, we will discuss and debate and sometimes conclude and not conclude how deep
Hmm.
can light penetrate? I sometimes say now, how important is that actually? Because we now know so much more about how important it is for what you just said, which is that the light is absorbed in the first place.
Hmm.
That's step number one, that we actually can create a scenario where we help the light be absorbed. Once it's absorbed, you know, how deep does it go? How deep does red light go? How deep does near infrared light go? Does it matter?
So I actually do think it matters a little bit. First of all, I
Yeah.
think it matters to understand why you would use one light over another or how you would combine those lights maybe in different
Yeah.
ways. And I think we'll talk about that later because we've
Yeah.
certainly taken all of this into consideration when we've designed our products. But that issue of absorption is the first part of the penetration story. So we will call this the
Yep.
depth of penetration into the body. So when we're talking about red light, we know that red light um, doesn't penetrate very deeply into the body. It does an amazing job of getting into the surface. So our skin, or if you were to put it into the nose or into the vagina or the rectum, you'll get in around 1 to 2 millimeters. And so what happens essentially is that the red interacts a lot more with chromophores that are at the surface. And so
Yep.
when it comes into the surface of our body, the surface tissues, there's a lot that just kind of grabs onto it. It gets absorbed by these things. So it doesn't penetrate in deeper than that, usually around 2 millimeter range. In contrast to that, the near infrared light doesn't interact nearly as much with those chromophores in the chromophores at the surface, and so it's able to penetrate much more deeply. Now, the challenge is actually giving a number that you can feel confident in terms of the depth of penetration. It's pretty much impossible because when you look at the studies, they really, really vary. And
Yep.
I mean, up until about 2025, the consensus was we're probably not going deeper than around 40, 50 millimeters. That's like the deepest that we saw the penetration for the most part. Like, so it's multiple centimeters. It's going in deep. It's remarkable. But then in 2025, there was this study that was published that showed that near infrared light was measured as passing actually fully through the thorax of the
Yeah.
body.
Yeah.
And now it's not importantly, it's not passing through unchanged. There's not a lot of it that's passing all the way through, but there are measurable photons that are coming out on the other side. So we know that that penetration is very deep. And there's another issue, in addition to absorption, that's different between these two lights, and that's scattering. So
Yeah.
the red light scatters more when it comes in. And so you can picture like a ball coming in and like bouncing back up
Yep.
instead of going straight down. So the near infrared light doesn't scatter as much. And so when you're looking at them in combination, and so this is why I do think it's important, is that if you're talking about a particular condition that you're trying to treat. So let's say that you want to treat like the metacarpal joint or something, right? Like there's not a lot of tissue there. You don't have to get in too far. So you know that you really are going to be wanting that combination of getting at the very surface because you're going to be a lot of stuff going on at the surface and then getting in more deeply. Whereas there are some other applications where okay, maybe there isn't really anything that I need to do at the surface here. I just want to go in all the way. And so you do see some studies, for example, with the brain research that
Yeah.
use exclusively near infrared light. They're not interested. But as I've looked at more and more and more studies, you really see that at least over the last few years, people have used a combination of light for things that in the past they only used one light type or another. So, for example, skin. People would only use red light for skin. Well, now we know that there's benefits to combining the red and the near infrared.
Yep.
Are there cases there we might say you really only need red? Yes, but there are benefits to most skin conditions in terms of combining them. The brain stuff has been really interesting because you think that there's really no benefit to having that, superficial, but the research suggests that there are benefits to combining the two. And so, yeah, I think it's important to understand what you're doing and how these different wavelengths are penetrating differently. Um, but at the same time, as you said, is it really something that you are going to mess up if you choose
Right.
to only use a combination of red and near infrared light? No, you're not. Now, could you mess it up if you chose to only use red light? Yes, you could. And could you mess
Right.
it up if you only choose to use near infrared light? Yes, you could.
Yeah.
So the combination, I think, is the powerhouse, but it's also important to think about your target, how deep you want to go, and then build your device accordingly with like changing the ratios of light chips or something along those
Right.
lines.
Yeah. So speaking to that, the deceptive part is that we've already identified that near infrared light is not visible. And most of the light in the red light therapy products that we see appears visible. Um, Interestingly, this is a great example in our panel, which is one example of like you can see all the dots that aren't shining. Well, those are actually near infrared light bulbs. And we do have a setting, which is kind of interesting. It's an interesting thing for the mind. We have a setting where you can just run the near infrared on our panel.
Mhm.
Kind of, you don't feel the experience as much almost because you don't see the bright light. But in our wraps, even though you see one red light growing, this little light actually has three chips in it. Two of the chips are near infrared. So almost all of the products we've made at Fringe, especially just general healing products, we do a 2 to 1 near infrared to red. And, we could just say, "Oh, that's because it goes deeper." That's not exactly it. Can you speak to a little bit about some of the pathways that the near infrared that you and I discuss sometimes, just talking about things like its interaction with water
Mhm.
or, its effects on blood flow and things like that? So
Yes.
we do.
Yeah.
We
Yeah.
definitely do lean at Fringe towards more near infrared, in our products.
Right, except when we've built our wand and our face mask, which are meant to be more superficial, right? So that's
Right.
where we have a
Right.
one
Yep.
to one ratio of near infrared to red
Yep.
versus our other products, which are a 2 to 1 ratio of near
Yep.
infrared to red. And that just speaks to, are we trying to kind of match and get a lot of that surface interaction happening, or are we focusing more on going a bit deeper, and getting that deeper penetration? So you mentioned water, and this is definitely a really interesting story. And you and I have been talking about this now for years, and
I know.
it's starting to kind of get some traction.
Yep.
But the research is there. There's not a lot of studies, but for example, we what is very clear is that water is a chromophore for near infrared light. It absorbs near infrared light. So when near infrared light hits some water, it's going to get absorbed, especially at some of those longer wavelengths. Um, that was thought to be a problem by all of these early researchers. It was thought that, oh, it's a waste. We can't, we go through water and we lose the near infrared light. I mean, it's water, right? What does water do? Well, it turns out that water does a lot. And when water interacts with near infrared light, there are some changes to that water that make it different and potentially make it more efficient at producing energy and possibly doing some other things than its earlier state. So it's something that we think about a lot when we talk about being outside in the sun and these light wavelengths passing all the way through our body and our body being filled with water. Um, I strongly suspect that that's one of the most important things that sun is doing for us. So
Yep.
these water changes, the term that's most often used is called the structuring of water, and this is like the fourth phase of water. Jerry Pollack's research. It's more complex than light structures water, but I think the main point is that interactions of near infrared light with water in the body are causing changes, chemical, structural, physiochemical changes
Yep.
that change the way that water functions. Like if you look at every single cell in our body, it is full of water. If you look
Yep.
between the cells in our body, it is full of water. If you look at our blood, if you look at our lymphatic tissue, we are the majority water, and it's really, really, really important. And so there are ideas that as that water changes structure and the viscosity of it changes, that can be one of the factors. It may also change the way that energy signals pass in that water medium.
Yeah.
So
Yeah.
I suspect that we're going to find out that this is critically important to the red light therapy story and the benefits that we see so consistently, but it's not been even remotely clearly unraveled yet, in terms of its mechanism. So I'm looking forward to that. So
Yeah.
that was one of the questions that you asked me. You'd also mentioned about blood flow. So
Yeah.
blood flow actually could be related to this water story in part,
Yep.
but we also know that red light therapy relates to the synthesis of something called nitric oxide, which is this little tiny gas molecule that, when it's present, helps blood vessels to get bigger and lets blood flow more readily when there's this process of what's called vasodilation, so the blood vessels dilating. And anytime you've got better blood flow, that blood is carrying your oxygen and it's carrying your nutrients and it's carrying away waste. It is so important. So blood flow improving is a really important element of red and near infrared light therapy. And we
Yep.
know that the near infrared light has a greater effect on nitric oxide production. So as we said, like that shared pathway of that cytochrome C oxidase is between the red and the near infrared light. Some slight differences in terms of how it interacts, but
Yep.
then this water pathway is entirely unique to near infrared light, and the nitric oxide pathway is going to be greater with our near infrared light. So you can see that there's really like this shared pathway, this different pathway, and then this pathway that's shared but is predominantly affected by near infrared light. So it's really amazing how much what we call like experimental or preclinical research has been done in red light therapy, where we've unpacked these mechanisms. Like, we've really
Yeah.
looked deeply into how it works. And so for us, coming into it, it's just been amazing being able to look at this body of
Yeah,
literature.
there's so
There's
much.
so
There's
much.
so there's so much. There's many things that we read about now where there's very little, and so you're left to try to speculate
Mhm.
and imagine and, connect the dots, and we still do that, I think, in many ways with light, but yeah, there is a lot of foundational science to go back on and just, be able to say, well, why did you guys pick this wavelength? I mean, we get these questions a lot, and it's like, well, we have a reason why we picked every wavelength, but then we also get to say, but also, please don't get so fixated on one wavelength, knowing that we receive this vast spectrum of wavelengths from the sun. There's no way that one specific wavelength is what you need
No.
to heal this specific thing. And also, LEDs deliver a spectrum of wavelengths. So even though we list a product at 650 or 670 or whatever, you're receiving a spectrum of wavelengths. And so, yeah, there is a difference between these ranges of wavelengths, the red wavelength range versus the near infrared wavelength range versus, all these others. But yeah, there's no way there's no way that one specific wavelength, is what we need, and so that's really hard because that's some messaging in the market now, and
Yeah.
and we just have to continue to be nerdy and share our message and help
Yeah.
people try and learn and understand about what they're investing in, and what they're buying. So I think we've kind of covered have we covered everything? So I always summarize by saying red light therapy in general energizes the machinery inside the cell, and
Mhm.
that the cascade, or like the series of events that comes from that is just very naturally what that cell is doing anyway, which is churning away and working at whatever its job is. If it's a little cell that builds bone, then it's in there building bone, or if it's building collagen or elastin or whatever it's doing. But there's more to the story when light is absorbed than just energizing a cell. There's these incredible, effects on water, effects on blood flow. There's effects on inflammation. There's sort of like what I would say, what we talk about more is most people don't say, oh, I need more blood flow in my shoulder joint. They just want pain to be gone. They want movement, to be better. But surprisingly, that's a lot of things happening, for
Absolutely.
pain to be gone and movement to be better. So we can get a little granular and talk about energy and blood flow and these types of enzymes and reactions, but the outcome is healing. I mean, very much so. If you were to summarize what light does, is it stimulates how our body naturally heals, brings blood, nutrients, reduces inflammation, energy, and potentially this ability for light to affect the water in the region, be that through the structure of the water, the energy that or the charge that the water is carrying, that is going to be pretty cool when we can maybe talk intelligently about that even more.
Agreed. Agreed.
Yeah.
And I think that's bang on. Light heals. Light heals.
Yeah, absolutely. Okay, so let's go into let's just summarize because you've touched on this a little bit, but clinical, because this is really all that people ask us every
Mhm.
single day. All the questions come in. Could this help this? Could this
Mhm.
help this? So, what are the best applications for red? Very specific red. And like you said, we have red only options in our
Yeah.
skin products, our face and neck mask, also our transvaginal or our pelvic one option as well. Anywhere where we felt like having just a red option made some sense, then we put it in there.
Exactly. And so you just nailed it. It's anytime there's a superficial problem, right? So if we're talking about the skin, we would be looking at things like acne as being the main superficial issue. So acne, of course, is most responsive from the perspective of kind of healing the acne or getting rid of the acne lesion. That would be blue light therapy. But then the red has been studied as coming in and helping to decrease the inflammation. So it's like a supporter for the whole
Yeah.
process, right? It'll decrease the inflammation, help with the oxidative stress, and help with the cellular repair process. But I still struggle with really I saying that even for the skin, just using red is a more appropriate application than using red and near infrared. Because when you
Yeah.
think of the structure and the depth of the skin, um, you have your epidermis and your dermis and then your subcutaneous tissue, right? Like you've you're
Yeah.
once you get into the dermis, you're needing near infrared light. So most of the scientific research on skin therapy has focused on using red light only. It did for many years. It started to layer in near infrared light and it's showing benefits. I definitely think for things like wound healing or scars, which need to get in deeper, you want that combination of the red and the near infrared light. The
Yeah.
other application where red has been used almost exclusively is hair growth. So those
Right.
hair follicles are very superficial. There are a few studies, not very many, they've combined with the near infrared light and they've also shown benefits. And when I think about putting light onto the head, I think if you're going to shine light onto the head, the brain is right underneath there. Why don't we include both? It makes
Yep.
much more sense to me to do that. So I really think that combining red and near infrared light, even in these more superficial applications, makes good sense. Um,
I'm rolling to our head wrap because I think we made this for brain health, but it has a very well studied red light wavelength range in it for hair growth. And
yeah,
so, no, we don't say FDA approved for hair growth. The crazy thing is, we'd have to go make another one with like these very specific criteria that would have the same wavelength in it. And then we'd have to apply for it to be FDA approved for hair growth in order to say that. Right now, we just generally say, blood flow and
yeah.
these very general claims, but at the end of the day, I can't put it over oh, maybe I can, but you know, the red and near infrared is combined in here.
Mhm.
So
Now
yeah, that's
yeah. Now in terms of the intravaginal, like using the pelvic wand, one
yeah,
thing that may be read only is microbiome support, because
right.
that is not a deep penetrating thing. That is a superficial. So that's an area. And then as you said, we've structured these products so that they have a mode that is red light only. And that would be really for people who are it's not so much that it would be for a particular clinical application. It's more for comfort when people are heat sensitive, because
Yeah.
the near infrared light generates a little bit of warmth and some people have extremely sensitive tissues Our
Yeah.
face tissue and our pelvic tissue is more sensitive than other tissues in our body. So we
Yes,
have that programming there.
so many blood vessels too,
Exactly.
so many very superficial blood vessels. So,
Yeah. So just to
yeah,
recap, we intentionally designed the face mask and the pelvic wand to have a ratio of 1 to 1 for the red to the near infrared light because we want to get more surface application than we do on most of the other parts of the body, where we've
right.
changed that ratio to 2 to 1. So that's the one thing. And then the other thing is we've included these modes that allow you to use red light only should that be either indicated, let's say you did want to just work on microbiome support or you were heat sensitive, then you have that option.
Yep. Okay, so that kind of leaves the obvious for near infrared, but let's talk about it. So
Hmm.
what are the, most common conditions for near
Hmm.
infrared, and also reminding everybody near infrared has a really big range.
It sure does.
Um
Yeah.
um and we have started and will probably start doing even more in playing around in some
Yeah.
of the larger numbers, so bigger waves
Hmm.
of light that travel with that near infrared. So, yeah, so kind of review that with us.
Absolutely. So the one application where, if you look at the scientific literature, the majority of studies have used exclusively near infrared light is brain health. So a lot of brain research using only near infrared light because the rationale is, well, the brain is not superficial. So why would you use red? Almost all of these studies find benefits. So they found amazing results with things like major depressive disorder, with Alzheimer's disease. It's been used in stroke rehabilitation, in Parkinson's disease. And so we know with our traumatic brain injuries as well, like our concussions, our CTE, that's another area that's been investigated. So we've got things like mood, we've got neurodegenerative disorders, we have the traumatic brain injuries, and then we also have childhood disorders like autism and ADHD. And most of those, or I should say, all of those studies have used near infrared light. Some of them have used near infrared light exclusively, and then sometimes it's combined. It's important. There's a lot of arguing that goes on in the scientific community about the light penetration into the brain and how could this be working. It is so clear that the light is doing something very powerful when it's applied to the head. Is it penetrating through the skull into the brain? We don't actually know that, but what we do know is that it works. And we also know that in a living organism, not in a cadaver, we have this interconnectedness of structures and fluid, right? So if you shine light onto the forehead, for example, and you irradiate the blood in that area, and then you get it into the lymphatic vessels that are draining in the head, um, you are potentially using that as a conduit to get light into the deeper structures of the head. It's not going to be the photons of light, but it'll be the change that has happened in that carrying medium, right? And especially if we find out that water is something that is particularly affected by light, which I suspect it is, but it's never a part of these brain conversations. The brain is full of water. Um, so all that to be said is that near infrared, its claim for exclusive independent use is brain. But we also have a body of research that uses red combined with near infrared. And so for our purposes, we chose to combine them both. Then we can get the additional hair benefits, we can get the superficial vasculature and everything. And there's the scientific clinical research that supports what we've done. So there's that. If we look at the musculoskeletal research or the research on nerve health, usually that's a combination. Well, the musculoskeletal especially, it's really always a combination of the near infrared and the red, right? You want to get deep into that tissue, and you also want to deal often with some superficial stuff going on. I have seen some nerve studies that, if they were talking about really superficial nerves, they used red only, but
Yeah.
that can, depends on where you're trying to target. In theory, if you were trying to get to a deeper nervous locate, like a nerve in a deeper location, you might not want to use red at all. You might just want to use near infrared, but that's certainly, um, there's no downside to using the red as well. Um, so that's really how that research plays out. For the pelvic health, um, there are it's kind of split. There are definitely some studies that use only red, and that's going to be really good for like vaginal atrophy or vaginal dryness. But if you're trying to get the light into the deeper region of the pelvis, like if you're trying
Yep.
to get the
Im
ovaries, trying to get the, the uterus, you need that near infrared light. It's just and
yeah,
the pelvic musculature.
which is interesting because when we were going to make the pelvic wand, if you recall in the beginning, it's like the first thing you do is just pull all the studies and see what are people doing, what kind and there was and then look at what do people have in the market, and there was a lot of wands with just red in them. And I was like, "Well, I feel like all the things we're gonna be talking about, people would have tremendous benefit from the near infrared light."
Mhm.
Just really, when you're talking about pelvic pain and
Yeah.
medical conditions and inflammation and not just a stage of life, sort of changes. People
Yeah.
are using the pelvic wand for very significant, you know, medical problems that they have, and it's helping them. And I'm very happy we put the near infrared light in that wand.
Yeah,
Um,
I should also mention, I didn't talk about this when when I was talking about the brain, um, health research,
right.
is that even though it's predominantly near infrared in the, like, 800 nanometer range, there are some studies and some products that include that longer wavelength, and so when we
Yeah.
looked at the literature, the decision was made to actually include 2 wavelengths of near infrared light, so that shorter 850 and then that longer 1050,
Yeah.
nanometer range, and so I think people can probably hear that we've been very, very intentional in the design of our products. They're not all the same, and so, for example, we often get asked by people, "Well, can I use the
Yeah. Yeah.
regular wrap on my face?" And absolutely you can.
Yeah.
However, you need to understand that there are less red wavelengths in that one. It's a ratio
Yep.
of 2 to 1 rather than 1 to 1.
Yep.
So subtle differences across our products, but very, very intentional by design.
Yes, and we're so honest when we answer those things because at the end of the day, it's red light and it's near infrared light. And are there going to be some benefits? We just had a question come in this morning of, I got the full body mat and I'm using that now, and can that replace
Mhm.
using the wrap? And at the end of the day, on some level, it probably can. Just depends, where you're getting contact, how long is the session, those sorts of things. So, yeah, I think at one point we sort of arrived at this point where we made a full body mat because I use our head wrap every day as my session and then just our regular wrap every day. And then I cycle through all the other things and kind of got to a point where I was like, I just kind of want to lay on some red and near infrared light for a part of my day, and be able to receive that light in a session and know that I'm in some really good ranges. And are they perfect? Meaning, do I have the perfect wavelength for, maybe the eczema on my, hand? Maybe not.
Mhm.
But I'm still getting benefit from it because I'm
Yeah.
in a range of wavelengths that are still going to be beneficial because like I said, you can't laser in on a wavelength doing a specific, thing. All the wavelengths have these general, same mechanisms, with some nuance to the effectiveness, I guess you could say,
Yeah,
of them.
I would agree.
So, okay, well, what else? Red and near infrared light. Lots of similarities,
Mhm.
definite differences. I think we've highlighted that the depth of penetration is different between the two. And um, for those reasons, very common sense, our skin and transvaginal pelvic wand products offer a red only option for superficial uses, but everything else we make does have double the amount of near infrared in it because of that ability to have a deeper penetration, an effect on blood flow in the area, blood and lymphatics, affecting our water structure, and yeah, really the depth of penetration with that light being a, a a bigger one. I think something you and I have discussed to kind of conclude this is we're very interested right now in talking about brain health. It means so much to me that we continue to learn about it and teach about it and provide answers for people, because I think people are very concerned when they're coming to us and saying, "Hey, I'm considering using this for concussion or dementia or Alzheimer's or Parkinson's." They should be. Um, and we go down this road of like, how do we describe these bigger near infrared wavelengths that we're using? It's not necessarily true that they penetrate deeper. It's maybe more accurate to say that they have a more vast
Yeah.
penetration or a vast distribution of light.
Yeah, yeah, I agree. I don't think we have an answer to that right now, but I'm
Yeah.
comfortable saying that by having the two wavelengths in there, we're going to have broader benefits than if we just had the single.
Right. Exactly. So,
And of course, I do
okay.
need to clarify there for everybody. And Ali, I actually think we really need to start changing the way that we describe our products to list the full spectrum of wavelengths, because
Yes.
people are under an impression that, like a laser therapy, there is a single wavelength in your red light therapy device, but
Yep.
it's not. It is a range of wavelengths with in which there is a peak wavelength that gets reported as
Yep.
the wavelength. And so if for anybody listening that has heard marketing around a magic wavelength, and if your
Oh,
red light therapy doesn't include 630 nanometers, it's not going to work. It's not at all
true.
true. It's not true, and it's not the way that science works, and it's not the way that biology works. So LED lights
Yeah.
emit a range of wavelengths of about plus or minus 30 nanometers or so. So if it says it's 650 nanometers, it'll actually contain light that's around 620 to 680. And so important take home message, there's no magic wavelength. Red light therapy with red light, with near infrared light, um, does a lot of different things, but they cross over. There's
Yeah.
so many shared commonalities between a specific product that has a certain wavelength that's stated, or a certain
Yeah.
type of light. And that's why, we're never going to be a company that goes out there and says you have to buy our products because they are the only
No.
ones that do this. That's not at all true. There are a lot of products on the market that can be beneficial, and it's just important that people understand what they're using and why they're using it. And
Yeah.
we want to educate people as to why we designed our products the way that we did.
Yeah, for sure. So we'll put that on our to-do list because we'd be one of the first
Mhm.
to be going into, okay, we're not just changing how our wavelengths are listed, but we're taking this as an opportunity for people to understand wavelengths,
Yeah.
which is dropping down 10 levels in detail, which is fine. And I agree with you. I absolutely agree with you. And if the wavelengths change, which let me tell you,
Mhm.
everything around here seems to change very regularly. Every year it's like, "Oh, just learned that.
Yeah.
Now we gotta change this." And it's not the easiest thing when it comes to making product to make those changes, but it is the right thing to keep it
Mhm.
progressing to, being the best that we can make. So, yeah. So we will put that on our to-do list. Okay, thanks everybody. We'll talk to you again soon.